All right, so these are the notes for section 6.3. Going to change a little bit how we work with our sine and cosine functions now. Instead of strictly graphing them on like a unit circle and just keep rotating, now our our angle measure is going to be on an x-axis. So it's going to be slightly different than how we were graphing them before, sort of on the unit circle. And we see this a lot in different in the sciences and earth sciences and different things like that. So we see sort of, well, we really, before we even talk about the sine and cosine, we want to talk about just periodic functions. And so like heart rates often have sort of a periodicness to them. May not be exactly the same every time, but there's a certain certain interval or period. And so period is related to frequency. It's actually the inverse of the frequency. So it's like if we're talking about, if this was a heart monitor, then how many seconds between the top of this beat to the top of the next beat. So that would be considered sort of the period of this thing. Although it doesn't have to be the peak to the peak, it could be the valley to the valley. It could be any one key point here, and where it gets repeated, you notice that that period is the same as that period is the same as this period. So the period doesn't really matter what point. Usually it makes sense to kind of call the max to the max, the min to the min. It's just easier to visualize. Here we can see a periodic function here. It's sort of dropping instantaneously, so it's almost like not a function, but often that will just be like a dashed line because it just goes straight down. In this case, we can assume it's a little bit over as time goes on. It's never really instantaneous drop. But so the period here again could be from here to here or from here to here. The period we're going to assume is constant with these. We're going to oversimplify things here. And again, another example of something that might be periodic. Periodic just means it kind of continues at regular intervals. Okay, in this case, period function is a function f such that if I put in a value for x, so let's call this x, this is the x coordinate, so the particular value of x. If I go one period away and I ask what the function of x plus 2 plus p is, sorry, I jumped over one, to p, then I should get the same output, right? I should get the same output. Now, there are other times when I get that same output here, but that's not a period, right? That is not one period. The period is, it's going up to a maximum, it's going up to a maximum. So from here to here, that's a period, okay? And then every time I evaluate the function at x plus some multiple of that period, we would get the same value, all right? So that's what it sort of means to be periodic. Now we're going to talk more specifically about how that period, now notice here, the period here was at a particular value and it's the same. So it's the same value, doing the same thing essentially. But more often than not, we're going to think of the period as, a peak to a peak. Sometimes these sinusoidal functions will have a baseline going through the middle of them, and sometimes we'll think about this to this as being the period as well, or the minimum to the minimum as being the period. Doesn't really matter, but you just got to be careful. I can't call this to this a period, right? Because here we're going up, here we're going down. It's got to behave in the same way. So the function's going up, the function's going up through the baseline. So this might be considered a period, but not to this one, okay? And then I'm going to open up a PowerPoint video and do the rest of the day one notes. All right, so we're going to use a little bit of a PowerPoint here to graph some, to look at the next page or so of notes. This is for section 6.3. If you look at the PDF of the notes, you should be able to click. Oh, actually, I posted a YouTube link to this video. It's kind of a goofy video of a math teacher trying to describe what a sinusoidal curve is. Probably the video will make more sense if you wait until a couple of lessons to go look at it, but you might go look at it if you're interested. Actually, in parts it might be a little bit creepy, but it's a math teacher singing sort of a love song to his sinusoidal curves. All right, let's go. Let's look. I'm looking now on the notes, middle of page 1. Okay, so we're talking about here, we're going to graph sine. So the x value will be the angle, so the angle measure. And then the y, or the output here, is going to be the sine ratio, right? So the ratio. And we're going to do it from one period. So we're going to go start at 0, and we're going to go all the way to 2 pi. And so if you would put in those values for me, pause this video, and figure out what the sine of 0, the sine of pi over 6, all that are. So find what all those are. All right, so with some of these, it might be a little bit harder to graph. We're going to graph them sort of on an xy coordinate plane. Normally, when we graph xy coordinate planes, we we have units like 1, 2, 3 on the x-axis. But here, since our x is our angle measure and it's in radians, we'll also use that same kind of scale on our x-axis. Okay. And now what we want to do is plot these points. So, sine of 0 is 0. Sine of pi over 6, that's 1/2. So it would go about here, right? So 0 and then half. Square root of 3 over 2. Square root of 3 divided by 2, that's going to be something like 0.86, right? So we would convert these to decimals so that we could probably graph them a little bit nicer. But, square root of 3 over 2, that would just be about 0.87. All right, so plot all of those, and you can see that you get something that kind of looks like this. And then, of course, we would plot those. So as the angle measure changes, that's the x-axis, we're going down the x-axis, it's like as the angle measure changes, the y is, what we're graphing. So we're graphing in this case, the sine, so we're graphing the height of that point as it went around the circle, right? So at pi over 2, which is here, our point was here. The next slide sort of helps visualize this a little bit better. So this is kind of what the sine looks like. Now it continues over here. We just limited our x values or our thetas from 0 to 2 pi. Notice also that goes through one full period, center to center. Now this is a center to the center value, or what we call the baseline, but that's not one full period, right? We have to go up, down, and back up to the starting point. That would be the same as this value here. So one full period in this case was 2 pi. All right, let's look at a couple of things we need to know. What is the domain for sine? The domain is negative pi to pi. I'm sorry, negative infinity to infinity. The range, what can we get out of this thing? You look, what's the height? What's the minimum? What's the max? What's the min? So that's just negative 1 to 1 inclusive in that case. What is the period? Period seems to be just 2 pi. And then if we think about it, this graph continues. See if I can get this to kind of show up. This graph continues back over this way, right? And this would continue over this way, right? So we only did it from 0 to 2 pi, but you can see it goes through the origin. So think about what this looks like in terms of even and odd. And I think you can see that the sine x, this is an odd function. Because if I put a negative x in, it's the same as the negative of sine x. And then for cosine, that's going to be even. We'll see that more in a minute when we get to cosine. All right, so this is kind of a good visual here. This is what we're basically doing. As the angle rotates, we're thinking about a unit circle, and we're thinking about what's the, for sine, we're looking at what's the y coordinates. It's 0, it's -1, it's 0, it's 1. So think about this as the baseline going through here. So it's 0, it's 1, it's 0, it's -1. Now up here we're doing cosine, and that's in terms of the x value. So you think about x value here is 1, then it goes down to 0, 1, 0, 1. Well, sorry, -1 over here. -1, so it's -1, goes up to 0, goes up to 1, goes back down to 1. So the x, the x is what the cosine is looking at. The y coordinate of the point is what the sine is looking at. Okay. All right, so in that first graph we did, oh my gosh, how many did we do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're not going to plot 13 points every time. We're really only going to plot 5 points and then just kind of sketch it in. All right, so let's start with sine and let's graph that. So let's start with 0. What is the sine of 0? Sine of 0 is 0. And then we go plot that point, and then we go a period away. So period in this case is 2 pi. So what is the sine of 2 pi? That's also 0, so we plot that point. We make a scale. Remember, we're going to use radians, not decimals, on the x-axis. All right, then we go halfway between 0 and 2 pi, and that's pi. And what is the sine of pi? That's 0. We'll plot that point. And then we'll go halfway between those points. So we'll do the sine of pi over 2. And what is the sine of pi over 2? That's 1. And then halfway between pi and 2 pi, that's 3 pi over 2. So what is the sine of 3 pi over 2? That's -1. So we're just going to plot those 5 points, and we're going to sketch that in. Okay? And you know, we'll practice a lot more. I mean, it's not always going to be this simple. There's going to be translations of this, stretching, shrinking, moving up, you know, translating up, translating left, translating down, translating right. So it's going to be a lot more complicated than just this simple y equals sine x. But you got to know what the basic sine of x looks like, the parent function, so that we can transform it. All right, cosine now. Let's look at what that looks like. So let's start with 0 for that. What is the cosine of 0? All right, that's 1, so we're going to plot that point up here. What is the period for the period for sine? The period for cosine is the same. It's 2 pi, so we're going to go to 2 pi. What is the cosine of 2 pi? That's also 1, so we're going to put our scale in so that we have those key values. The first value, the last value, and then cut it in half and cut those in half again. So 5 key components. So halfway between that is pi. Cosine of pi, that's going to be -1. We'll plot that point as well here. And then halfway between, pi over 2. So what is cosine of pi over 2? That's going to be 0. And we'll plot that point. And then halfway between pi and 2 pi, 3 pi over 2. What is the cosine of 3 pi over 2? That is 0. And so we plot that in. So you can see here for cosine, it starts high. And of course, you know, if we continued it, it would come back down this way, right? And then this would also come back down this way, right? So we can see that as far as the y-axis, which is this, we have an even function. All right, so this cosine is even. Now, not always. Any kind of translation we might do might affect it, and of course it wouldn't be even. But y equals cosine x is an even function.